Hello? 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 Anybody out there? Well, it's been a few weeks, a few months since my last update, but well, I'm not going to say I'm back full-time with videos just yet. It is still summertime, and as those of you in the Midwest know, that here we get like 3 months to try and cram every outdoor activity we can into those 3 short months. And it's been a pretty mild summer here in Wisconsin. We definitely haven't had as warm a temps as we have in years past. So I've had to take advantage of the what mild weather we've had and gotten a lot of riding in, got a lot of races in, had some success this year. So it's been a great season. It's pretty much has wound down. So I'm no longer racing. Now it's just some charity rides. My wife and I go and do a 100-mile bike ride up in Door County. For those of you familiar with the Wisconsin area, it's a beautiful part of Wisconsin. It's actually on the peninsula of the thumb if you look at Wisconsin. Beautiful part of the state, and there's a 100-mile ride. And we go do that, and there's a race around Lake Winnebago, which is in the roughly in the middle of the state, south or east part of the state, about midway up, and so I'm going to do that. But anyway, enough on the cycling. I got some time here since I don't have to train as hard right now, so I thought, let's do some train stuff. For those of you who've watched the video know that I had a little mishap with the Liftout bridge that I have, and I said that I was going to get around to putting in a system by which it will cut the power to the tracks leading up to the Liftout bridge, and that was a project that I meant to do. Train took a dive off the edge of the layout, and now I really intend to do it. So I went on eBay and I got, let's see, if these are just little limit switches, and this one, they come in different styles. This one happens to have a roller bearing up at the top here, and you can, I don't know if you can hear it, but it has a real positive clicking engagement. And the nice thing about this is a couple things, and why I picked it. First of all, it's got mounting holes here and here. I don't know if those will show up, but so I'm going to be able to put some screws through here and mount it on the side of the layout. But it also is nice, and it's got on the side here, and this might not show up as well, but on the side here it has a built-in wire diagram telling you which of these contacts is normally open and which one's normally closed. And then that's kind of the nice thing. I plan to use the normally open, obviously, so when it's up and raised like this, power to the track is cut, and then when it's engaged, power is routed through. But if for any reason you needed to, you could buy this same switch and use the normally closed aspect of it. I can't think of any applications, well, that I have, but maybe there are some out there. And these were, I think I picked them up. I picked up 10 of them off eBay for like $8, free shipping. Came directly from Hong Kong, so it took a little bit to get here, but you know, and I actually like the fact that I got 10, just in case. You know, anybody who works with relays, especially mechanical relays, you know that the spring mechanism inside, especially when you're only paying a few bucks for these, may fail. So that way, if it fails, I've got a bunch of extra ones, or if I find another application for them. So that's going to be the topic of today's video, is getting these installed, and I want to go show you how I go about getting these installed. So, and they've got two different, you could solder on the lugs, or what I hope to do, and I think I've got the right wire, but you can just, on this blade, there's the mating plug to this. Mating socket, actually, this would be the plug. And then that way, like I said, if they ever fail, I can just pull that off without having to desolder them and be good to go. So, let's, I'm going to do a quick wire diagram just to give you an idea of how I'm going to wire these in, and then we'll flip over to the layout and I'll show you where I'm going to put them and how I'm going to install them. Alright. Okay, getting real high tech here. Here's the schematic for what I plan to do here. sorry for the somewhat crudeness of it, despite the fact that this is what I did for many years, drawing schematics. I always did it on a CAD program, and I don't really have access to the CAD program at the moment, so you get a hand drawing. So this is essentially what I'm looking at doing. The lift-out bridge is actually, it's part of this circuit obviously, but not part of the limit switch in and of itself. It will engage the limit switch, but electronically it doesn't have any connections to this. So on each side of the bridge I'm going to install one limit switch using the normally open contacts. I don't know if they'll show up, but this is the common lead on the bottom here, and the top lead here is the normally closed lead, and I want the normally open lead. So when it's up in this position, this lead is not connected. Now it's engaged, and current and voltage can flow through, and then opens when the bridge isn't installed. So, and using this, what I will do is just cut one rail on either side of the bridge, actually 3 times on total. On the one side of the lift-out bridge, there's a switch, and it's pretty close to the bridge itself, so I'm going to cut a rail on each of the main line and then the diverging route, and then those can be common wired together to the limit switch on this side. And then I'll just I'll get feeder wire from this side and this side, and then short it on this side. So nothing much to it. Here's the limit switch, normally open, limit switch normally open, and we'll wire 2 of these up and mount them. So that's a basic schematic of what's going to take place. Okay, so here's one side of the bridge that I'm going to be installing things on. Here's the track leading up to it. So I'm going to measure back and take 2 of my longer engines and have at least a 2-engine lead, 2-engine gap from here to wherever the gap is. So probably like 18 inches or so. Put the gap in, drill some holes and run wires, and then those will come up to here, and then the plan will be, and I'm going to have to do a little bit of measuring, but we'll mount the limit switch here, so when the bridge is pushed down, this engages. So we'll figure out where best to have this. The other thing you can do is to see how far you need to plunge this, is when it actually makes contact. And you can do that by taking an ohm meter and just putting your leads on these 2 and then start depressing it. And I think that with like this one in particular, it doesn't engage the contacts until it actually is completely down. So you want to make note of that depending on your limit switch. If it only depresses it that much, it may not actually close it. You might actually have to hear that click for it to engage. So I'll have to figure out where to mount this, and then we'll get it engaged. And that's basically it. I'm going to see if I can clean this wiring up once it's installed. It's going to be a little bit difficult though, because it's kind of got to be out in the open. And then we'll do the same on the other side. So really kind of simplistic, but we'll see if we can make this look a little bit neater and hopefully save engines from taking a nosedive. Okay, so here's the lift-out bridge installed. You can kind of see it here. And I talk about it briefly. The lift-out bridge actually is just a 2x4. It's gonna be, I don't have real good lighting in this area. Let's see if it'll focus. So this portion here is just a 2x4. The track is mounted to a 2x4, and then for safety, I've got 1x2s on either side. And not that a 2x4 needs structural rigidity. I mean, you can see this is only like maybe a 36-inch span, so it's really not going to flex under the weight of HO scale trains. But however, this is more of a catch in case anything derails going over the bridge. So that's the bridge. You know, this started as a temporary solution, and much like everything that you start temporary, it ends up becoming a permanent solution. But I do intend to someday redo this. For the time being, though, it's sufficing. So here, and kind of going, explaining the lift-out bridge a little bit, I have a lot of leftover computer parts. I end up building computers for people as a side hobby, and as they give me their old computers and they don't want them anymore, I strip them for parts. And sometimes those parts are useless, old power supplies that you can't use anymore. But a lot of times what I'll do is I'll cut the wiring out and I'll save it. So you can see here, this is actually what's referred to as a Molex connector. It's actually a company, but I'm sure that it's just a 4-pin header, and this happens to be the plug, and then here's the socket version. And these are generally which you connect to your hard drive. These are a little bit less common, but sometimes you'll find them for fans, external fans and such. And then I've just got it wired into my Romex that I use as my bus wiring. And then here's the feeder wires. And this is also from computers. These are actually, as my company has been upgrading our network to gigabit Ethernet, and now in some areas 10 gig Ethernet, we can no longer use Cat5 wiring. We're actually upgrading to Cat6. So as we rip this stuff out, it is going to be thrown out. They don't even reclaim the stuff for the copper, mainly because it's too small and too much work. So I will take lengths of it and use it as feeder wires. This is anywhere from 26 to 30 gauge wire. It's solid copper wire, which is, in my opinion, perfect for feeder wires. Now, it's a little on the small side. Some of you are probably shuddering at the thought of a 26 gauge feeder wire. However, I run more of these maybe than most. I'll run them every 3 feet, and then I don't have to worry about them acting as a fuse and burning out if I've got a short circuit. The concept being that if you have more of them, you don't have to run as much current through each feeder wire. So, and the other great thing is that each pair, depending on what kind of wire it was, you'll have a solid and then you'll have a white with a stripe. And that makes it really easy as I was wiring the layout, because I knew that everywhere there was one wire that would have a certain color and on one rail, and then the solid color on the other rail. So this is how I connect my bridge and get power to the bridge. Just interlock these two. Sometimes it's a little finicky. And there you go. Now I've got power to the bridge. And these aren't necessarily made to be reused, plugged in and out over and over like some others, but you know what? These were free, and I had them, so I'm using them. And when I want to disconnect the cable, just wiggle them loose, and then they're done. Connection's broken. Now this isn't going to be the most scientific method to doing this, but I'm going to go ahead and press that into place. It's fully engaged at this point. I'm not getting a lot of deflection on the arm, so I know that I'm not going to be overstressing the limit switch in the location that it's at. And then I'm just going to go ahead and trace its location here. Let's see if I can get, I won't be able to do that, but I know that's fully engaged. And then I'm also going to mark where the roller is on the bridge itself. A little earthquake there. So now I've got the limit switch marked, and I can take the bridge out then and come back and drill or mark the holes, hopefully, so I can drill holes in here and then screw it into place. And that should be, yeah, you can feel it's good and engaged, but like I said, not deflecting the arm too much to the point where it's going to put stress on the mechanism at all. Okay, so here I have the limit switch installed. Just drilled 2 holes here. There's one in each corner, and installed the screws. And you can see that when the bridge is in, it'll press down on it and engage the switch itself. So the next step will be to cut the track and get the wiring put in. Unfortunately, I don't have the bladed plugs like I was hoping, so I'm going to end up soldering directly to the switch itself. It's not too big a deal. I'm going to leave some extra wire though in case I ever have to replace these. I can just cut the wire then, and I'll have a little bit of length to solder in the new one if one of these switches ever fails. So alright, that'll be the next step. Okay, so I went ahead and used just a razor saw from Atlas. Dremel tools work nice, but the blade thickness, or the saw thickness that you use, not sickness, that you use can leave quite a huge gap. But the Atlas saw that I have actually ends up leaving a really nice fine cut. And if you can see the size of my finger here, but there is the cut itself. And like I said, I do it on a slight angle, and then that way there's very little discernible gap as the train passes over it, or there's not as much of a clunk. And you can see I did mar up the ties just a little bit, but not too bad. And actually this section of track is hidden, so you won't see it. One of the critical things with any electrical project is to make sure that you, especially when you need to isolate something, is that you don't get too far without testing what you're working on. And a good digital ohm meter, I've had this one for years. I actually had to buy it when I was in school for some classes, but it's served me well ever since. And basically, if you're not familiar with one or what it can do, you can measure resistances, and this is great for DCC projects and stuff like that. You can measure DC voltage, AC voltage, and then also current, but then you have to switch these, but we won't get into that at the moment. And then resistance. But the resistance is great because, let's see if I can do this and hold it at the same time. If you can still see the display, if you just touch the leads together, you can see that it goes to 0 because there's no resistance there. Now the important thing here for us is that means that there is continuity between these two leads, which is obvious. So when you break them, you get a measurement of 1, which is, well, in this case infinite, because there's no other numbers after it. So you can see continuity, so I have 0. So why am I showing you this? Well, I want to make sure that I have isolated the 2 pieces of track. So here's my gap, and there's still continuity there. So that's not a good thing. I need to look at my wiring or my cut to make sure that I actually have isolated everything. I have a feeling that I have a jumper wire on this track here that's making connection between these two. So maybe I just need to cut that, or cut that and use that as my jumper wire for the switch itself. So, but that's you always want to do that if you're trying to create isolation between anything and anything electrical. Test it before you power it on, especially between 2 sides. Making sure both rails are isolated from each other, things like that. So, okay, so I've got the limit switch installed, and I've got the track feeder wires. And as it worked out, I didn't actually have to solder any new wires to the track. These are actually the feeder wires. So what I did was I just cut it, and since this is ultimately a light switch, is what we're doing here. All I'm doing is splicing in a switch into the middle of this feeder wire. This was perfect because this one side of the feeder wire comes from my bus, the other side goes to the track. And having said that, it doesn't matter which side is the feeder and which side is the source coming from the bus wire, because again, it's just a switch. So when it's open, it's open. When it's closed, current will flow. And so just like if you were wiring a house, a light switch in your house, same principle here. You can reverse them, everything's fine. The only thing critical here is that you want to use the bottom lug, which is the normally open, not the top lug that was normally closed. So this way, when that's engaged, you'll have current. So I'm going to go ahead and, because I don't have the lugs like I wanted, I'm just going to go ahead and solder it right onto there. So I'm going to hit it with a little bit of flux. Now, these are made to be, you can solder them, or you can use the bladed lugs. I believe that the preference, however, would be for the bladed lug. So you're going to want to solder quickly. Don't apply too much heat. The more heat you apply, that heat will transfer into the plastic itself and start to deform the housing. So you want to try and apply solder and heat as quickly as possible and get them soldered on. I'm not sure if I'm going to be able to do this on screen and get it done cleanly, but we'll give it a try here. So just my solder from before, apply some heat. I usually give it a little tug. Everything's good there. And this one's going to be a little bit harder. Okay, so again, little tug on the wire. It's in snug. It's in snug. And it's pretty clean. You know, you could, you know, depending on your installation, I might just try and hide those wires. But actually, they're hidden pretty well. All right, well, moment of truth. We kind of know that it already works. But just to be sure, there's a new engine coming down the track. Bridge is not installed because the bridge would be right where the camera is. And you can see the limit switch is raised. So that means there should be no power to this portion of the track here. So go ahead and start them going. And sputters and dies. Perfect. Now if I just engage the limit switch, you can see he gains power again. So reverse him, get him off the bridge and away from danger. So test successful on this side. We'll flip over to the other side and do the same. Okay, essentially the same test. Limit switch is raised, bridge is not in, past the gap, perfect, and it's engaged again. Just what we want to see. Back him out of trouble, back onto the main, he's past the gap. Exactly what we were hoping for. Well, there you have it. My safety project, I guess. My layout is now OSHA certified. I don't know. I probably wouldn't get any VPP stars for safety or anything, but at least I know that my engines won't be able to take a nosedive. This, of course, doesn't prevent me from backing a train onto those sections of track. That's just my own fault then, as is a nosedive. But at least I know here that as my son gets older and he starts to run trains, I at least there's some safety there. And I can't really blame my son. I was the one that took the train off the edge. So, but if there's any ever guests here running the layout and the bridge isn't installed for some reason, now I know that that track is isolated and dead without the switches being engaged by the bridge itself. So I'll throw a link in the show notes. Like I said, I got these off eBay. I just did a search on limit switches. You can get them from DigiKey, Mauser, but I went on eBay, like I said, $10 I think total, eight something, $10, let's say, for 10 of them. Like I said, I bought extra just in case, especially because I have a tendency to just sit here and click them for some reason. I don't know why, OCD, but whatever it is, they're fun to click. So thanks again for sticking with me with this lull in videos. That I've had a long and fruitful season actually for cycling. I won a few races and actually managed to win the Wisconsin State Crit Championship in my category, so that was kind of a fun achievement this year, and looking forward to getting, like I said, to some little bit more casual riding, and hopefully have some more videos. My next one, I hope to do a little bit of the detailing project on the Wisconsin Central SD40, and then getting back into modeling. I've got backdrops that I cut when it was nice out, so I can start painting those and getting those installed, maybe working on scenery and everything again. I know I've had some questions about doing some scenery and maybe do a layout tour update. So, but thanks again. Thanks a lot for sticking with me, everyone, and we'll see you whenever the next video is. I'm not going to say next week, but we'll see what happens. So thanks a lot, everyone.